Right, good day, grade 12s. Here we are again with Mr. Moyo. We want to look at Physical Sciences Paper 2, mainly focusing on electrochemical reactions. That is your question 8 and question 9 in your Physical Science paper. If you go through all the national papers that we have, you will realize that it is an important section. It is a section where you need to score marks. It's a section where I need you to get all the marks that you can get in the examination. So our electrochemicals is divided into two sections. So what we're going to do now in this session, we'll be focusing on part number 1, where I explain in detail the galvanic reactions. And please do catch me on the second episode, where I'll be focusing on how to answer the question, how to score the mark in the examination. So let us begin with part 1, the galvanic reactions. So we said with your teachers, we agreed that electrochemistry is we are studying the interrelation between the electrical and the chemical reaction. So with the galvanic cell, we are going to start. It's also called voltaic reaction. As you can see in your slide, we are going to explain. Galvanic reactions is an electrochemical reactions that focus on chemical energy being converted to electrical. So there is an energy change there. We are moving from chemical reaction to electrical energy. So whenever we are looking at this galvanic cell or this voltaic cell, we call it an exothermic reaction. Why are we calling it exothermic reaction? Is because of heat is produced or energy is produced. So normally, for you to test whether something is an exothermic reaction, you will realize that at the end of the reaction, the test tube gets hotter. So in a galvanic reaction, we are saying electrical energy is produced from the electrochemical reaction, as you can see on your slides. So another valid point about this galvanic cell is that it is self-sustainable. So this galvanic cell, it is self-sustainable, meaning in other words, it is spontaneous reaction. So you'll find that in the exam, the language that we'll be using is that we are looking at a spontaneous reaction. So you need to know that we are referring to a galvanic cell. When something is spontaneous, in other words, it is self-sufficient. You don't need to make use of external effect for it to start working. Immediately when the apparatus are set up, the chemical reaction starts to occur. So another valid point about a galvanic cell, we are saying in a galvanic cell, positive electrode is a cathode, while a negative electrode is an anode. Very, 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 very important. I will repeat. We are saying a positive electrode is a cathode. It is where reduction takes place. Then we have our negative electrode, which is our anode. It is where oxidation takes place. So I want to believe that your teachers have dived deep on this topic to say we have something called an oil rig, where we say in an oil rig, oxidation is the loss of electrons, while reduction is the gaining of electrons. So I'm not going to be explaining in detail, but I wanted to give you a simpler way of remembering the oxidation and the reduction, that we still follow the oil rig system. And then we also in grade 11 touched a bit on something called the red cat, where we used to say reduction is cathode and anode is oxidation. So we used to call it red cat and anodes. So coming back to galvanic cell, we are still emphasizing that cathode is positive while anode is negative. So grade 12, it is very, very, very important for you to understand that. Because of when we're moving to electrolytic cells, you will realize that the opposite is also true. So very, very, very important for you to check that. And on our next, we need to talk about the setup. The setup of a galvanic cell, it is different from the electrolytic cell. Why are we saying so? It's simply because of it involves two containers, or we call it two beakers. But if you now touch on the language of science, we call them half cells. So we have two half cells in between here. Then we need to talk about the flow. Remember I said to you, in a galvanic cell, we are moving from chemical energy to electrical energy. So that means there should be a movement of ions. But how do they flow? They flow from the anode side to the cathode side. So we'll be moving from negative to positive. So we'll be having a salt bridge that will be connecting. We'll be having connecting wires. I will show you here on the slides when we talk about the setup and how it looks like. But what I'm trying to emphasize is you must understand the movement of electrons. Electrons are moving from the negative to the positive, which is anode to cathode through the external circuit. We also dealt with this in grade 11 where we spoke about something called the cut ions and the anions. So I just wanted to emphasize here to say whenever we talk about the cut ions, which are the positively charged ions, they will be moving from the anode via the salt bridge to the cathode side. As I've explained the electron flow to say we're always moving from anode to cathode. So we are also emphasizing that the same ions, which are positively ions, they will be moving from the anode side, then it passes through via salt bridge to the cathode side. So it is very, very, very important for you to know that. And they will be also migrating towards the anode side using what is called an internal circuit. So remember when I started, I said this galvanic cell, it is spontaneous, so it's continuous. It's more like a circle. So as the electrons are moving from negative to positive, the reverse is also true. So it's very, very important for you to pay attention to that as grade 12s. Right. Another point that we need to also raise in a galvanic cell is the fact that electrons in galvanic cell always consist of different metals. Remember, we said in grade 10, metals are a good conductor of electricity. Very, very, very important for you to realize that. So even here in grade 12, we still move on the same agenda to say electrodes in a galvanic cell will be using different types of metals. Namely, the ones that we normally use are your platinum, your aluminium, zinc. So I will be showing you different types of electrodes that we use here in this topic. But it is very, very, very important to know that we use different types of metals. Now, in your periodic table, you know that we find metals in group number 1 as well as in group number 2. So those are the types of metals that you and I will be using, to be quite frank. So let's see how the setup of this galvanic cell looks like. Now, we want to talk about the setup. Every reaction that takes place, there are standard conditions that we follow. So in a galvanic cell, these are the standard conditions. If you check down on your slide, 1, always the temperature should be on 25 degrees Celsius. Or we can use the Kelvin scale to say it is 298 Kelvin. So that is one of the standard conditions that is very important. And please pay attention. They will ask you that in the examination. The second condition that we need to pay attention to is the concentration. The concentration should always be at 1 mole per decimeter cubic. So within those half cell, concentration will be there, but you need to measure an accurate quantity, which is 1 mole per decimeter cubic. Another condition that is very, very important that you need to pay attention is the pressure. Your pressure should be at 1,013 times 10 to the power 5 pascals. So, or you can simply say at 1 atmospheric pressure. So that is the pressure that we need whenever we are looking at galvanic cell. So in the exam, they're always going to ask you, can you state 3 standard conditions of a galvanic cell? So these are the ones that I've just outlined above here. Then let's talk about the salt bridge. I know you heard me talk about something called the salt bridge. It is a U-tube-like glass that contains a salt solution. Remember, ions need to move, and they need to move through a solution. So a salt bridge, it will be connecting the 2 half cell, which is more like a U-tube-like glass. But very, very important is the appliances that are inside there, the quantities that are involved there. So sometimes we use potassium nitrate, sometimes we use sodium chloride, sometimes we use potassium chloride. So very, very, very important to pay attention on the salts that we use here. And then, what is the function of this salt bridge? You are always going to be asked to at least name 1. So 1, it completes the circuit. So the primary function of this salt bridge is to complete the circuit. Number two, it is to maintain electrical neutrality of the half cell. So you realize that as you're moving from chemical to electrical, we need to maintain the electrical neutrality there. So that is the primary purpose of this salt bridge. I want us to talk about the setup. Very, very important for you to understand that. As you can see, we'll need a beaker on your slides. We'll need an electrode. So in this case, I'm using zinc plate as one of the electrode. Remember I said we need metal, so I'll be using zinc. We need another beaker with the solution. Then we are going to use copper plate. Right, so we said the setup, it needs two half cells. So I have the zinc plate, I have the copper plate with the two beakers there. Then I will need a salt bridge that connects the two half cells. So as you can see, there's my salt bridge there. What I'm going to do, I'm going to put a solution inside there, which is potassium nitrate. Then, because of I do not want that solution to be inside the two beakers, we normally put something called the cotton wool there. So you will be asked to label this in the examination. And then we'll be obviously including the solution in our half cell. I have sulfur that side on both half beakers. Then I need to put my voltmeter so that I can start to measure the electrical that is coming as an output in those two half cells. So I always put a voltmeter as an instrument to measure the potential difference that the chemical will be showing me. So what are the observations? Now, if we were to take you back, you realize that I used zinc and I used copper. But what are the observations that we get in this topic? One, we have the anode and the cathode. So our zinc was on the anode side, our copper was on the cathode side. So what transpired there? We saw that zinc will undergo oxidation, which is the loss of electrons. What happens on the loss of electrons? We realize that on the electroplate, in the electrode, on the zinc side, we are going to observe that the mass will decrease. But if you check what is happening on the cathode, because of these things are taking place simultaneously, we realize that copper was undergoing reductions where it was gaining the electrons. So what happened? The mass of the copper plate started to increase. So what is happening on the anode side, it impacts what is happening on the cathode side. So when the zinc was decreasing the mass, on the cathode side, the mass was increasing. Remember, these reactions are taking place simultaneously. Then with your half reaction, we can see zinc there undergoing a loss of electron, 2 electrons to be precise. And then on the copper side, we're also seeing the gaining of electrons where copper gains 2 electrons. So what happened to the zinc? So the oxidation number of zinc increases. I need to repeat this. The oxidation number on the zinc increases. So remember, we are saying electrons are negatively charged from grade 10. So now, what we mean by saying the zinc increases oxidation number, we are moving from the negative side to the positive side. That's why it is now zinc 2 plus on the anode side. Then on the cathode side, we are seeing a decrease because of when you are gaining electrons, you are gaining the negative electrons. So that's why we are observing a decrease in the oxidation number. So one of the things that you'll be asked in the exam, it will be, can you write an overall balanced equation? This takes 2 marks in your exam. So you are observing that we have zinc with copper, which also gives us zinc and copper. And make sure that it's always balanced. Another thing that I know that your teachers have explained, I'm just going to go over it again, it's your cell notation. Remember how to write the cell notation. We follow the ANC rule. I'm not referring to your political party, but I'm saying ANC, meaning A, which is the anode, N, which is the electrical neutrality, meaning the salt bridge, and then the C is standing for the cathode side. So if you can see on your slide there, I'm showing you that zinc undergone anode. So I have zinc, which was Zn, and now Zn2 plus, just to show that it lost electrons. Then the double line that I used there, it is the cathode, it is the salt bridge. That's why I said An. The N is for electrical neutrality. Remember, I said to you, the primary function of a salt bridge is to maintain electrical neutrality. So that is the double line there. And then when you go on the right hand side, you see that we have copper 2 plus, which is now copper, just to show that it gained electron. So that it means that is our cathode side. In one-to-many occasions, you will be asked to find the E cell or the electron volt, standard reduction potential table. You will be asked to calculate the EMF. So as you can see, the formula says cathode minus the anode. So at the back of the question paper for physical sciences, you always have what you call standard reduction potential table. So that's where you get these EMF values. So you're going to substitute there and find the difference between the cathode and the anode, and then you will get your solution. So as you can see with the example that you and I were busy with, we realized that zinc had 0.34 and copper had 0.76. And then the difference between the two in this case became 1.10 volts. So that was the standard reduction potential EMF of what happened between zinc and copper. So what are other observations? Just to continue as grade 12, I want you to also notice that what happens at the end of the reaction. Normally what happens is that the voltmeter will ended up registering 0 volts. Why? Let's answer that question. Because of the reaction is said to have reached equilibrium. As much as the reaction of zinc and copper was spontaneous, but remember the substances that are inside there, they elapse. So as they elapse, we are going to say at some point in time, the reaction has to reach equilibrium. What we mean by saying it has reached equilibrium, we are saying the rate of the forward or the rate of the oxidation, it is now equal to the rate of the reduction. So the state where the rate of the forward is the same as the rate of the reverse. In other words, the rate of oxidation equal to the rate of reduction, that is the only time where the voltmeter will start registering 0 volts. That means there is no electron transfer that is still taking place between the two half cells. Very, very, very important. So in that way, we are concluding by saying the cell, it is said to be flat. Remember, we are looking at half cells that we're reacting together. We are saying at the end, because of now the voltmeter is registering 0, that means the battery is flat. That's what happens in our everyday life. If we talk about a car that now the battery is no longer working, it is said to be flat simply because the rate of the forward, it is now equal to the rate of the reverse. The rate of oxidation has equated to the rate of the reduction. Very, very important for you to pay attention to that, grade 12. Another thing that I want to add again, it is that the concentration of that electrolyte in the cathode cell increases. So on an electrolyte, it is anode. All right, it is anode, and the EMF of a cell will increase while the concentration of the electrolyte on the anode is increased. So the cell potential decreases according to Le Chatelier's principle. Remember, grade 12, that these topics, they interrelate. We dealt with what is called chemical equilibrium before. So the same thing happens even here, whereby what is happening on the anode, the system will shift in such a way to counteract the change. So we are also explaining those observations. I just wanted to show you the setup again. If you can check what is happening on the gas electrode. If we put hydrogen gas there in your diagram, just follow the diagram. If we put a hydrogen gas there on that gas electrode, what happens? Remember, we cannot use a a gas. Because of gas, we say they are inert, meaning they do not conduct electricity. So I wanted you to pay attention on the setup there. So we are going to make use of something called the platinum. Why? Because of platinum or graphite, they will act as a conductor of electricity. So just to wrap it up, grade 12, when writing the cell notation, please pay attention of the anode to the cathode side. So in this case, if we used platinum, we're going to use platinum with hydrogen gas, and then to show us what happened on the outside, where we have the X element there. So please pay attention to that. Very, 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 very important, grade 12. So what have I done? I've just quickly gave you a summary of what is happening on the galvanic cell, the things that I need you to answer in your exam. So you need to pay attention to this, grade 12. So in a nutshell, this is what happens on galvanic cell. Remember, I said this topic is divided into two. So what we'll be doing, you and I, we will be meeting on the next episode where we talk about the electrolytic cells, and then we also engage on the questions around there. So what I want you to master is, please note the summary of this. This is where we collect marks in grade 12. So it is very, very, very important for you to check this. So if you check the slides, I've explained everything that it happens in and around this. So grade 12, we will meet again on the next episode where we'll look at the questions. And then I will be making use of the notes that I've given you to try and remind you and give you other ways to show how you can remember this, how you can recall this in the examination. It is very, very important for you to pay attention to that. So thank you so much, grade 12. I will make it a point that we meet on the next episode, then we dive into questions looking at what is happening here. I'm not sure if you have any other questions, but I believe that if you have any questions, you can contact us and then we'll be able to reach out to you. But this is generally what is happening on galvanic cell, mainly the most important things. So thank you so much. Please pay attention on the setup. We no longer ask learners to draw, but we ask learners to label. And we need learners to know what is happening here. So grade 12, thank you so much. Let's meet on the next episode when we are tackling questions. Thank you so much.